Good morning. This is your Stat Sensei, Mr. Spensei, and this is an exit ticket on the normal distribution inverse norm and also on central limit theorem. So, um, a survey determined the mean monthly rent for apartments in an urban area is 1,600. So, mean is 1,600 with a standard deviation of 400. What is the cost associated with the upper 10% of rents? I should say 10% of rents. All right. Well, if they give us a percent, that tells me I'm probably working with an inverse norm. So I'm going to go ahead and draw my picture. We know my mean is 400. But anytime they give me a percent, I put an X. And I go, oh, they said the upper 10%. So this is going to be up here. Remember, all percents are divided by 100. So we're going to shade this way from the top. So this is going to be 0.10 because that's 10 divided by 100. And we have positive infinity as our upper bound. So that's what we're looking for. And so this is going to be an inverse norm. Our lower part of, and it's going to ask us for the area. So we're going to have to remember that it's our PMS. So our probability is 0.10. Our mean in this case was actual value of 400. It's not a z-score. They're asking for the actual value. And our standard deviation was given to us or at 400. So we had a mean of 1,600 and a standard deviation of 400. Notice we shaded from the right, and we also need to make that notation that we're shading from the right. So, second vars, inverse norm, area 0.10, mean of 400, mean of 1,600. Keep messing that up. Standard deviation of 400, and we're shading from the right. And we end up getting 2,112.6207. So, $2,000, 112.62. And I'm just going to stop it at 62 because we're talking about money. All right. What z-score? Well, please remember all z-scores have a mean equal to 0 and a standard deviation equal to 1 are associated with the upper 10%. So we're still talking about the same type of problem, but now we're looking for a z-score. And remember, they gave us a percent, so this tells me it's going to be an inverse norm. So I know it's an inverse norm. It's a z-score. All z-scores are centered at 0. And we're looking for the upper 10%. Once again, if they give you a percent, put an X. In this case, the 10% is above it. Remember, it's always divided by 100. And we have 0.10, and we're looking for a z-score. So z-score, lower our area, because remember, it's our PMS. Our probability or percent is 0.10. Our mean for all z-scores is 0, and our standard deviation is 1. We shaded from the right. Second vars, inverse norm, area 0.10, mean of 0, standard deviation of 1, shading from the right, and we end up getting 1.2815. So z equals 1.2815. And it makes sense that this would be a positive z-score because we're above our mean of 0. So if we're above 0, we should have a positive. All right. What's the probability? Oh, we're looking for a probability. That tells me that's a hint that it could be the norm CDF or it could be a z-test. A random. Ooh, so A means 1. So in this case, N is 1. So this tells me I'm going to be using a norm CDF, and we're looking for X. We're looking for the probability that X is less than 800. So let's draw a picture of what this needs to look like. So if I'm drawing my picture, We learned up above that the mean is 1600. So I'm going to write that down here so I don't want to forget about it. The mean equals 1600, and we have a standard deviation of 400. So I just wrote that down. So our mean is set at 1600, and 800 is below it. So I'm going to put the 800 down here. And we're shading this way. And remember, you're shading to negative infinity. So when I go to write this, it's going to be a norm CDF. Don't forget our LUMO, our lower, our upper, our mean, and our standard deviation, which I know is not really an O, but it kind of looks like one. So negative infinity to an upper of 800 to a mean of 1600 and a standard deviation of 400. All right. So we're below 1600. So we should have a negative z-score. So second vars, normal, CDF, or we should have a value less than 50% in this case. Well, negative 9 raised to the 99th, that's the smallest value we'll take. The upper part of our shading is 800. Our mean is 1600, and our standard deviation is 400. And we end up getting 0.0227. So our probability is 0.0227. We'll box that in. That's a done deal. What's the probability that the mean rent of, let's change this and make this 36. Now, let's make this, keep it at 25. Mean rent of 25 apartments is less than 1200. Well, we're looking for the mean, which means we're looking for X bar. If we're looking for X bar, this is going to be a Z test. So let's draw a picture of what this is supposed to look like. Well, we know that the mean of the population is 1600 because they gave us that earlier, and I'm going to go ahead and note that down again. The mean is 1600. The standard deviation is 400. But we're looking for an X bar of less than 1200. So stat test, Z test. Mean of 1600, standard deviation of 400, X bar of 1200, and we have a sample size 25. So X bar, got to note it down, is 1200. N is 25, and we're looking for a less than, because we were looking for the probability that X bar is less than 1200. So let's see what happens when we do that. And we get the probability that Z is less than -5. And we get this thing right here. When you have that, if that number is a 5 or more, you can put approximately 0. 0.000. So approximately 0. All right. Appreciate you watching. Hope that helped and hope to see you on the next one. Thank you.